So we've been talking about single area OSPF implementation. So this is our reference topology. As I mentioned in the previous video, if you've only got one area, it's best to use area 0. In multi-area OSPF, area 0 is your backbone used to connect the other areas. In single area OSPF, it is the whole routing domain. Now, you're going to use the network command to indicate which interfaces, which subnets you want to include in that OSPF area. Now, this includes both the access layer networks that you actually want to move traffic between, and also the distribution and core networks that you want to move traffic through. So this 2.0/24 here, 1.0/24, and this 168.1.0/24 here. And also 3 and 10.4 and 10.8, but not the loopback, because the loopback is your link to the cloud. Now, one common misconception, something I've seen students do over and over and over again, is to declare all of the networks in the area on every router in the area. That is incorrect. It will not have it won't break anything, but it's the wrong way to do this. The right way to do this is on every router in the area to include the locally connected networks that are in that area. So, for example, if you do show IP route before you start OSPF at all, you look at those lines that have a C by them, where you'll see 172.16.3.0/30, or 192.168.10.4/30, or 172.16.1.0/24. Those are the networks that you're going to include in the OSPF area using a network statement. And also the appropriate wildcard mask. The wildcard mask is really important because with the wrong mask, you don't establish neighbor adjacencies between the routers, and also you may advertise the wrong kind of network, either more or less than you actually mean to advertise. So let's talk about, and of course you're going to do network and then the subnet address, not the physical, not the address of the physical interface of the router that's in that subnet, but the subnet address itself. This is another reason why getting your subnetting right to begin with is so important, because if your subnetting table is wrong, you're going to put in the wrong information here and at the interface and in lots of other places. And of course your wildcard mask and then your area. You have to now we specify the area with the network statement because we don't assume we're doing single area OSPF. We have the same command syntax whether it's single or multi-area OSPF. So let's look at the wildcard mask. Okay, so your wildcard mask is essentially the /32 255.255.255.0 minus the subnet mask. In this case, for example, 255.255.255.0. The inverse of that will be O.O.O/.255 rather. So this is why we call this an inverse mask sometimes, or you might hear me refer to it as a backwards mask. Inverse, backwards, wildcard, all the same story. Now, the fun thing here, to shortcut that mathematics for you, the arithmetic for you, look at the inverse over here. The inverse of this 192.2, so 255.255.255.192. That's a /26. The network interval for a /26 network is 64. Notice that the inverse mask of that /26 is 0.0.0.63. So you take your network interval, you subtract 1, and that's your mask, your inverse mask. You can also confirm this by taking that number, that 63, and the value of that of what the working octet in the subnet mask. You add them back together, and you must, if you've done it right, get exactly 255. If you get 254 or 256, you've done it wrong. by adding or subtracting wrong someplace. Um, in any case, so the quickest way I have to think about this, if I can't look at the mask right off the top of my head and do the math subtracting from 255, what I do is I think about the 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 interval which is associated with that mask and subtract 1 from it. So let's look at what this looks like in the networking statement, and let me move myself up here. And now I'm in the right place again. Huzzah! So there are two different ways to use the networking command. You can advertise the network using the mask. The other thing you can do is advertise the address itself using a wildcard mask of 0.0.0.0, which of course corresponds to a mask of 255.255.255.255. So you could look at the line that says L on that link and see what it is. Okay, sorry. I had a bit of a technical glitch. I apologize for that. What I meant to say was, when you look at your show IP route output, you'll see 2 lines for every physical interface you've configured that is being included in the routing table. One labeled C for a connected network, and L for the local interface. So if you're going to use the top method, method 1, the traditional method with the wildcard mask, you look at the C line. If you're going to use method 2, the interface address and an inverse mask of 0.0.0.0, you'll look at the L line in your show IP routing table, your routing table. Now, you need to understand both of these methods, because you might see either or perhaps even both of them on a test or your instructions or even a certification exam. Now, let's talk about passive interfaces for just a minute. So once you've set up all these networks in the routing domain, what if you don't want to advertise them all? Say, for example, these access layer networks. You don't want, in the interest of security, and we could also do this on the loopback as well, in the interest of security and limiting network overhead, you don't want to advertise OSPF messages into those access layer networks, because there's not an OSPF router on the other side to hear that hello message. It's useless. So what we can do is set these gigabit interfaces passive in each router's routing configuration. So what we do there, we go, let's see. So what we'll do here is use the passive interface command. Passive interface gig 00, or passive interface loopback 00, loopback 0. And these will all show up in your show IP protocols output. Now, if you have some adjacencies that you think should be forming but aren't, look at show IP protocols. Make sure you haven't accidentally set more interfaces passive than you meant to. And also, for the interest of security, make sure if you do have a link off the routing domain, either because that link is using another routing protocol, say BGP or EIGRP or whatnot, or no routing protocol at all, say if it's a default static route, your standard quad 0 route, make sure that interface, that exit interface that is serving the default route, is passive. You might even want to, say for example, you've got a floating default route that will only kick in if the primary default route is down. Even set that one passive. So there's essentially no right way. There's no one right way to decide and issue these passive interface commands. Just look at the ratio between the interfaces you have configured and the number of them that you need to use. If you have more interfaces that you need to use than you need to set passive, then set specific interfaces passive. If you have more interfaces that you need to set passive than you need to actually use for OSPF, do passive interface default, and then do a no passive interface on the few interfaces that you do need to include. So there's, like I said, there's 2 right ways to do this. There is a packet tracer, which I believe I have already demonstrated. Um, there is a video about that elsewhere, or actually, what I demonstrated was the lab, not the packet tracer. But if you're having trouble with the packet tracer, go ahead and watch my lab demo video for 8.1. No, 8.2.1.4, and go from there. Or maybe it's 8.2.4.5. Anyway, the next thing we're going to talk about is OSPF costing. Okay, thank you, and I'll be right back.